Hi there, I have a problem from Black Book of the G, which is a mathematical Olympiads, and we are going to see how to solve this problem. So we are given a polynomial of second degree, and we are given its roots a and b, and we are supposed to find its partial sums of a to the n plus b to the n. Well, we can actually also find partial sums, but we're only asked the limit. So, well, actually, when I saw this question, the first way I thought was I can express S1 is equal to a plus b, which of course I know it's just I can find some of the roots. S2 is a plus b times a plus b squared minus 2ab. This is a squared plus b squared. And I can actually just find all of the other ones. Sn is equal to a, so it will be a to the n minus b, n minus 1, b to the n minus 1, times a plus b. So each time I'm just separating one a plus b. And so this is, and if I just subtract the extra term, it will be ab parenthesis a to the n minus 2 plus b to the n minus 2. And well, I know here everything, and it's all kind of recursive. I can just add all sides, and here you can solve it with this way. It's just a bit long. Actually, it's arguable that it's longer because we will do also some extra stuff. Okay, so instead, so this way is valid. Okay, you can solve it. But instead, I will see if I can do it another way. So my goal, I will just change the index. I don't like r. So n is greater or equal than 1. I have a to the n plus b to the n. If I actually had that, well, but both of these are geometric. If I actually had that absolute value of a and absolute value of b is less than 1, then I could say that both of these are just convergent, and I can separate the sum, n greater or equal than 1, a to the n plus n greater or equal than 1, b to the n. And then I can just find it because, like I said, these are convergent. They just don't have the first term, which is 1. So this is just 1 over 1 minus a minus 1 plus 1 over 1 minus b minus 1. And then I would be done. I can maybe write this bit nicer. But so I need to actually show that if both of these roots have absolute value less than 1. So, well, I can do it. So from here, I know that the roots are equal to a and b is equal to, so minus this thing, which is 25, plus minus square root of, square root of 25 is just 625. And minus 4 times minus 2, 375. It makes us 8 times 375, which is 3000. So plus 3000, I can just say 3625. Over, I have 2a, 2 times 375, which is 750. Okay, which is, so if I simplify this one, 1 over 30 plus minus, and well, I don't know, what is this thing? 3625. Over 750. Okay, and I can pick a for the plus one and b for the minus one. So, well, here the one thing you can do is, so 360 is very close to this, and this is just 60 squared. And if you take 61 squared, of course it will be bigger than this thing. So you can actually just say 60 is less than 3625 squared, which is less than 61. And then you can just divide all sides by 750 and work with inequalities. Here I will be a bit lazy and I will only do it for 60. So because this thing is very close to 60, actually, it's only just like 25 more. Of course, it's not 25 more. This is very close to 60, okay? So I can say that this is almost 1 over 30. So like I said, you can just take a is equal to this plus, and then use this inequality, and then use it for b, and you can just do both, okay? This is just a bit shorter way. So this is almost 60 squared. So this is almost 60. over 750. And you can just expand this by 25 and you will get 85 over 750, which is of course less than 1. And also here both of them are just positive. So here I actually took A. Wait, maybe. Okay, this is actually the A because I just took the plus part. So, and this is of course positive. So A is between 0 and 1. Okay, A is between 0 and 1. So its absolute value is of course less than 1. And I can do similarly 1 over 30 minus 60 over 750. I mean, this is almost B. And I can again just do the same. This is going to be 130. So I can just say, again, just expand it by 25. It will be minus 35. So this will be equal to, well, I should have actually used opposite order. Let's say this is equal to, and B is almost equal to. So minus 35 over 750, which is, it's like 1 over 20. I mean, it's of course just bigger than minus 1, right? Because it's like closer to 0. And also, of course, this is negative. So I can say B is also just less than 0. So I can say B, so I found that minus 1 is less than B, which is less than 0. And also, well, I can just even use it here. 0 is less than A, which is less than 1. So from here, I can say both A and B has absolute value, which is less than 1. So what does that mean is that this thing is valid. I can go from here to here. This equality holds since both of these are convergent because this thing holds. And then this thing of course holds. If you have this equality, then this one of course holds. And well, to do that, I can just separate this minus 2. And so I will just do this now. I have 1 over A. I can just expand them both. 1 minus A and 1 minus B. So I will have 1 minus B at the top plus 1 minus A. So it will be just, let's delete this, 2 minus A plus B over 1 minus A times 1 minus B, which is going to be just 1 plus AB minus A plus B. So this is this term and this term, and I have minus 2. And well, from Vieta's formula, I just know all of this stuff now. Because A plus B is just this thing minus of this thing over this thing. So it's just 1 over 15. And A times B is just this over this, which is minus 2 over 375. 375. Okay, cool. Oops. So I can just do this now. 2 minus 1 over 15 is just going to be 29 over 15. And so this is also 1 over 15. So I can just expand this by 25. So it will be minus 27 over 375. And I can just add 375 over 375. It will be 348 over 375. You can just do those parts. It's boring. So, and if I flip it, it will be 375 over 348. And now I can just simplify these two. It makes 25. If I multiply these two, it makes 725, I guess. Yes. Also, I have minus 2. So this makes 725 over 348 minus 2. So if I multiply this by 2, I will get 696, right? If I subtract them, it will be 29 over 348. And if I simplify this, this is exactly 1 over 12. And this is our answer. Yeah, it's nice that, yeah, well, they picked the numbers nicely so that this thing would be just perfectly, I mean, it's a nice number. And yeah, this is end of it.